Core Pew Mathematics 1, Paper 1, Monday, 11th May 2020. Further Mathematics 9FMO. Answer all questions and ensure that your answers to parts of questions are clearly labeled. You should show sufficient working to make sure your methods are clear. Answers without working may not gain full credit. Question number 1. F of z is 3z cubed plus pz squared plus 57z plus q, where p and q are real constants. Given that 3 minus 2 root 2i is a root of the equation f of z equals to 0, show all the roots of f of z equals to 0 on a single argand diagram. So the complex conjugate is another root. So if we have one of the roots, alpha is 3 minus 2 root 2i, the complex conjugate is beta is 3 plus 2 root 2i. So it's minus there, it's plus there. So the complex conjugate beta is equal to 3 plus 2 root 2i is also a root. Now we need to find the sum and product for the conjugate pair. And to get the sum and product, we would have beta 3 plus 2 root 2i times alpha. So this would be, if you multiply alpha and beta, you will get 17. And you can do that with your calculator. And if you add alpha plus beta, if you add them together, you will get 6. So alpha times beta is 17. Alpha plus beta is 6. And you can do that using your graphics calculator. And this is a formula which I'm going to use, this idea. Alpha plus beta plus gamma is equals to minus b over a. Alpha beta plus beta gamma plus gamma a is c over a. And alpha beta gamma is minus d over a. And when we want to find c over a, c is 57 and a is 3. So c divided by a is 57 divided by 3. And that will represent alpha beta plus alpha gamma plus beta gamma. So c is 57 and a is 3. Now we know alpha beta is 17. So we substitute 17 for alpha beta. So that means alpha beta 17 plus alpha gamma plus beta gamma is equals to 57 over 3. Now we can factorize. I've put gamma in yellow. That yellow means we can factorize. If we take gamma out of the bracket, we will have alpha plus beta is equals to 57 over 3 minus 27 will give you 2. But we know alpha plus beta is 6. Alpha plus beta is 6, which we've done here in the calculator. Alpha plus beta is 6, which we had done up here before. Now we replace alpha plus beta with 6. So gamma times 6 equals to 2. So gamma would be, take 6 to the other side, it becomes 2 divided by 6. Gamma will be 1 over 3. Now you know your 3, you know alpha, beta, and gamma. The 3 factors. Alpha is 3 minus 2 root 2i. Beta is 3 plus 2 root 2i, the complex conjugate pair. And gamma is 1 over 3. So 3 plus or minus 2 root 2i must be plotted correctly in quadrants 1 and 3, quadrants 1 and 4. quadrants 1 and 4, which are reflections in the real axis. So it's like a reflection in this real axis. So the real axis is like the mirror, and you have a reflection. The real root must be close to the origin compared to the complex roots. So this is the real root, which is gamma, is 1 over 3, must be close. So if you imagine alpha, 2 root 2 is 2.8. So 2 root 2 is 2.8. So we want to plot 3 on the real axis and minus 2.8 on the imaginary axis. So the real axis is this one, which would normally be the x-axis. And the imaginary axis is this one, which would normally be the y-axis in Cartesian coordinate system. So we go 3 to the right and then minus 2.8 down. So 3 minus 2.8, we mark it there. We join the line. And 3 plus 2.8i, 3 to the right and 2.8 up. So that's the next one. And then gamma is 0.3, which is there and is real. So we just go 0.3, which is 1/3. So that is your representation on the Argand diagram. Question 1b, find the value of P and the value of Q. We know that alpha plus beta plus gamma is equals to minus B over A. But B is P and A is 3. So from that function which was given, B is P and A is 3. And we know alpha, beta, and gamma. So we substitute, that's alpha, 3 minus 2 root 2i, beta, plus gamma, which is 1 over 3. When you put alpha plus beta was 6, which we done in the calculator, plus 1 over 3 is equals to minus P over 3. So to get P, 3 times 19 over 3, you take this 3 to that side, 3 times 19 over 3, it gives you minus P, and times by minus 1, P is minus 19. And the next one we use product. Alpha times beta times gamma is equals to minus Q over 3. If you put all of that in your calculator, if you put alpha times beta, you get 17 times 1 over 3, which will give you 17. And then you times by a minus, so Q would be minus 17. So your two answers are P is minus 19 and Q is minus 17. So this is the answer for part of question 1A. The second part of question 1A, the third part of question 1A, and question 1B. Question number 2. Explain why integral from 1 to infinity 1 over x bracket 2x plus 5 dx is an improper integral. Because the interval being integrated over is unbounded. That's why. Or because the upper limit is infinity. The upper limit has infinity on it. Or because a limit is required to evaluate it. So because the upper limit is infinity or unbounded. So those are the reasons. So we can say the integral from a to b f of s dx is improper if either one or both of the limit is infinite. And in this case, the upper limit is infinite. So one of them is infinite. So f of x is undefined at x equals to a and x equals to b or another point in the interval. So one of the limit is infinite. Question 2b. Integrate from 1 to infinity 1 over x bracket 2x plus 5 dx. So what we want to do, we want to express it as a partial fraction. So we take the one fraction and we want to express it into two fractions. So the reason why we do that is so that it's easier to integrate. So what we can do is we would multiply the left hand side by x bracket 2x plus 5. Multiply a with x bracket 2x plus 5. Multiply b with x bracket 2x plus 5. So that means it would cross out on this part and you're left with 1 on the left hand side. And you have a, the x would cross out for a, you'll be left with 2x plus 5. You have b, the 2x plus 5 will cross out, you'll be left with x. Now we choose some numbers to substitute that would make one of them 0. So if we pick x to be 0, 1 will be equal to a bracket 2 times 0 plus 5 plus b times 0. The reason we picked 0 was because 0 times b would be 0. So you can now find a. Because b is now 0, you can find a. So a would be 1 over 5. Because 2 times 0 is 0. So 5 times a is 5a. And 1 equals to 5a. A is 1 divided by 5. Now we substitute another number. And for this case, I like to take easier numbers. So I pick 1. So 1 is equal to a times 2 times 1 plus b times 1. So what we get is 2 times 1 plus 5 gives you 7. So it will be 7a plus b. But we know a is 1 over 5. So we substitute 1 over 5 for a. So 7 times 1 over 5 plus b is equals to 1. So b would be 1 minus, you take this to the left, 1 minus 7 over 5, which will be minus 2 over 5. So you can write the fraction as 1 over 5 x minus 2 over 5 bracket x plus 5. So we can now integrate. So we want to integrate 1 over 5x, and we want to integrate 2 over 5 root 2 over 5 bracket 2x plus 5. So 1 over 5 can go out of the bracket. We have 1 over x left. And 2 over 5 can go out of the bracket. And we have 1 over 2x plus 5. When you integrate 1 over x, you get ln x. Integral of 1 over x is ln x. Now, you want to integrate 1 over 2x plus 5. You look at the function. When you differentiate 2x plus 5, you get 2x. Now, in order to compensate for that 2, because at the top is 1, we have to multiply by a half. And when you multiply, you get 2x. You want to get 1 at the top. So you want to multiply by a half. So that is why half times 2 over 5 would give you 1 over 5. So that is why you have 1 over 5 ln x minus 1 over 5 ln bracket 2x plus 5. Now you can factorize, take ln 1 over 5 out of the bracket. Go 1 over 5 there, 1 over 5 there, can come out of the bracket. So you end up with ln x minus ln 2x plus 5. When you subtract, you divide them. When you subtract the logs, you divide. So it's 1 over 5 ln x divided by 2x plus 5. Now we need to start to work out with the limits. The limits go from 1 to infinity. So let's find out the limit as x tends to infinity. What this means is as x becomes a very large number. So when x becomes a very large number, we will replace x there with a very large number, say as large as you can think of, and replace x there with a very large number. So imagine this, a very large number divided by 2 times that large number, so double it, plus 5. Adding 5 doesn't make much difference. It's like adding 5 to 300,000 billion. Doesn't make much difference. So the 5 can be considered as 0. So it's a large number times 2 times a large number. So one of them will cancel. You're left with a half. So imagine that large number over here is infinity. It will cancel. And you're left with a half because that 5 is like 0. So you would have 1 over 5 ln half. And since we're integrating from 1 to infinity, if we put x equals to 1, it will be 1 over 5 ln 1 over 2 times 1 plus 5. 2 times 1 is 2 plus 5 is 7. So it will be 1 over 5 ln 1 over 7. So what we have now is 1 over 5 ln half minus 1 over 5 ln 1 over 7. 1 over 5 is common, so we can take it out of the bracket. And then you're left with ln half minus ln 1 over 7. When you subtract logs, you divide them. So it's 1 over 5 ln half divided by 7. Half divided by 7 is the same as 7 over 2. So 1 over 5 ln 7 over 2. So A is 1 over 5 and B is 7 over 2. So that's the answer for question 2A. And note, we also use this idea to integrate the function below. That is part of 2B. That is the rest of question 2B.